pretty good job at your inequalities so far. And now we're going to start getting interesting a little bit. We're going to talk about compound inequalities today. And then in the next day, we'll talk about absolute value inequalities. And these get a little more challenging. So let's take a look closely. So compound inequality is two inequalities combined by either an intersection or a union. And we use short little words for those. Our intersections we use and for unions we use or. And they have two totally different meanings. Two totally different meanings. So first of all, an intersection. A compound inequality containing and it's only true if both inequalities are true. So for example, if I had something like x is greater than 6 and x is less than 9, both, let's make it less than or equal to 9. Both of those have to be true in order for my inequality to be true. So if I said the number 10, it's greater than 6, but it's not less than or equal to 9, so 10 does not work. 10 does not fit in that set. What if I picked 4? 4 is less than or equal to 9, but it's not greater than 6, so 4 doesn't work. But 7 works because 7 is greater than 6, and it's also less than or equal to 9. And the nice part is about an intersection with and is I can write this as one inequality. I can start with my smallest number, 6, and I got my point pointing at 6, so 6 is less than x. And then I already have my x, so I'm just combining it into 1x here, and then I bring down my sign over here, less than or equal to 9. So I just combine those two, and if I graph this, it would look like this. So if I have 5, 6, 7, 8, 9, 10. Well, I'd have an open circle at 6, a closed circle at 9, because it's less than or equal to. And then it's all the numbers in between there, isn't it? So I like to kind of put it above so I can tell. So there we go. That would be for an and. It always intersects like that. It connects. I could write it as one inequality. So let's try a couple of those. So looking at number 1, they might write it with the actual and sign, the actual and sign. And if that's the case, just solve each individually. So I'm looking at this left one. I can add 3 to both sides, and I'm left with y is greater than or equal to negative 8. Then I go do the left one. Add 3 to both sides, and I have y is less than or equal to negative 4. Well, like I said, anytime it's and, I can write it as one inequality. So I start with my smallest number, negative 8. And I got the point going at negative 8. So I say negative 8 is less than or equal to y, which is also less than or equal to negative 4. And then I could graph this. So I usually just start 1 to the left of negative 8. Negative 9, negative 7, negative 6, negative 5, negative 4. Something like that. So it looks like we have a closed circle at both of them. Closed circle at 8, a closed circle at negative 8, and a closed circle at negative 4, and it's all the numbers that are in between, right? So anything from negative 8 to negative 4, those would work in that inequality. Well, they also might be written as one inequality. Looking at number 2. It's all combined, isn't it? This is where it's kind of new, isn't it? Well, let's look. Where's my variable at? It's in the middle, okay? So what's my first step to get r by itself? Well, we need to subtract 8, right? I can't touch that negative 2 because it's connected to the r yet. Well, our rule is whatever I do to one side, I do to the other. Well, now I have 2 other sides, right? I have an inequality here, and I have an inequality here. So I should probably do it to both other sides. So if I'm going to subtract 8 in the middle, I better subtract 8 on the left, and I better subtract 8 on the right. So let's go ahead and go through. So 6 minus 8, or 6 and a negative 8, gives me a negative 2. Bring down my less than or equal to sign. And this is gone, so I'm left with negative 2r. Bring down my less than sign. And 10 minus 8 is 2. Yeah? Well, same thing here. What do I do to get r by itself? I divide by a negative 2. And whatever I do to one side, I do to the other side, or all the sides. So I divide by negative 2 over here, divide by negative 2 over here. Oh, what did I just say? I'm dividing by a negative. What happens when we divide by a negative? Signs get reversed. So if I divide by a negative 2, negative 2 divided by negative 2 is a positive 1. Well, I just divided by a negative, so I have to reverse my sign. And I'm left with r in the middle. Same thing, I divided by a negative, so I have to reverse my sign. And I'm left with -1. Well, obviously this inequality doesn't make a whole lot of sense because we want the smallest number on the left, and 1 is bigger than -1. So let's flip that around. And I want to say -1 is less than r, which is less than or equal to 1. And now we can go ahead and graph this. So same thing like the other one. Start with -2, -1, 0, 1, 2. And looks like I've got an open circle at -1 because there's no equal to, closed circle at 1, and then we connect them. So the ands always look like this. Always look like this. I can write them as one inequality, and they have a nice intersected graph. Nice intersected graph like that. Okay, ors are a little different. A union, a compound inequality containing or, is true if at least one of the inequality is true. So only one has to be true. Okay, just one of them. So for example, let's look at that first one that I did. I said x is greater than 6 and x is less than 9. As long as one is true, the whole thing is true. So if I said x is 12, would that work? Yeah, it's greater than 6, isn't it? 12 is greater than 6, so it works. As long as one's true, the whole thing is true for or. Same thing if I pick 3. Will that work? Yeah, it's less than 9. Okay, so it works. Could it be 7? Yeah, because it's greater than 6 and it's less than 9. So as long as it works for one, it works for the whole thing. That's the only difference with or. And ors are always written as two separate inequalities. So if you notice, I have two separate. Okay, it can't be written combined like and does. So I just got to do them all separately. So I look over on the left here. -1, -1, left with a is less than 3. I'm going to bring down my or sign here, my or word, I guess. And then here we need to add 1. So I'm left with a is greater than or equal to 4. So now when I graph this, I'm dealing with 3 and 4, so I'm just going to go with 2, 3, 4, 5. Well, let's see, I have an open circle at 3, and closed circle at 4. And I'm saying numbers less than 3, so going that way. And numbers greater than or equal to -4, so I'm going this way. So basically, any number less than 3 or any number 4 or greater. So that's almost every single number besides like 3, 3.5, 3.7. Those are the only ones that don't work. Right? If I plug 3.7 into either one of these, it does not work. Okay? But if I plugged in 8, 8 works over here, so it works for the whole thing because it is or. So I basically have kind of two arrows there. Well, if I look at number 2 now, so let's do the left one first. Add 7, add 7. I'm left with 4k is less than or equal to 32. And then we divide by 4. So k is less than or equal to 8. And we bring down my or right away. So I know it's or, don't forget it. And over here, can't do anything with that -9. It's connected to the k, so I got to get rid of the 12. So a -12, or subtract 12. That's gone. Don't forget your minus sign. I'll remind you that every time. -9k is greater than or equal to 18. Well, look what's going to happen. I'm dividing by a -9. So don't forget, if you divide by a negative, sign needs to get reversed. All right, I flip my sign. And 18 divided by -9 is -2. Well, there we go. I can go ahead and graph these now. So I have -2 over here. I can probably count by 1 still. -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. There's 8. I'll just count by 2 dashes though. There we go. I don't want to get too crowded. So I have a closed circle at -2. And it's going to the left. I'm saying all numbers less than -2. And I have a closed circle at 8. And I'm saying all numbers less than 8. Well, if I think about this, like 8 works, 6 works, 4, 2, 0, -2. Everything less than or equal to 8 works. So I don't really necessarily need that red graph, do I? Because my blue graph is going to take care of all that, isn't it? So I could leave it just like this. That's perfectly fine. But to be a little neater, I simply could do this and say 8 and everything less than 8, because that includes this guy. So I'm okay with either one of those graphs. Okay, you could have this graph or you could have this graph. This bottom graph is a little bit neater, a little more technically correct. You know, it doesn't look as goofy, but they both work. I'm okay with both of them. That's all there is to it. So just ands and ors. And just remember, ands I can write as one inequality, ors are always two separate inequalities.